Problem 7. To determine if certain representations are functions, we want to determine if they have repeated x values. So for it to be a function, each input can have only one output. So if one of the x values has multiple y values that go with it, that would make it not a function. So if we look at A, it's a set of points here. So look at the x values, and there's 1, 7, 3, 11, 9, 23, 15, 35. Okay, so those x values are all unique. None of the x values are repeated. So if we had another point that had the x value 1, say, that would make it not a function. But because there's no repeated x values, yes, this is a function. Okay, so A is a function. Okay, look at B. B is another representation of a function. It's a function mapping, which really we can look at that function mapping and turn it into points if we wanted to. But if you look at the -1, it goes to 25. So that's like the point -1, 25. The 3 also goes to 25. And then the 5 goes to 10. So that's what the function mapping would look like if we wrote it as points. So again, if we look at the x values, we have -1, 3, and 5. And none of those x values is repeated and has separate y values. So this is a function. So it's okay that that 25y is repeated. It's just we can't have a repeated x value with different outputs. Okay, so B is a function. Okay, look at C. So C is a graph, kind of like a sideways parabola. To determine if a graph is a function, use the vertical line test. So that means that if you draw a vertical line anywhere on the graph, it should only cross the graph at most one time. And if it crosses the graph more than one time, that means that there's repeated x values and it's not a function. So for this graph, we could draw a vertical line right here, and we cross the graph twice. So that means that this is not a function. And that's by the vertical line test. So it just has to fail the vertical line test at least one time in order for it to not be a function. Okay. So we also did some function evaluating from graphs. So if you look at this graph of this function, if we wanted to find f of 2, that means look where x is 2. So look at where x is 2 on the graph, and we want to see what y is at that point. So x is 2 right here. So if we go to the graph, that's the point 2, -2 on the graph. So that means that when x is 2, y is -2. Okay, so f of 2 is -2. Part B asks us to find x when f of x is 0. So that means if f of x is 0, that means that y is 0. So we want to look at the graph for whenever y is equal to 0, and we want to see what x is at those points. So y is 0 anywhere the graph crosses the x-axis. So right here and right here is where y is 0. So that's the point -5, 0 has a y value of 0, and the point 0, 0 on this graph has a y value of 0. And this asks us to find x when f of x is 0. So the x values at those 2 points are -5 and 0. So x equals -5 is one of the options, and also x equals 0. So whenever you have the input, like part A, and you're finding the output or the y value, there's only going to be one answer. But for part B, when you have the output and you're finding the input, it's possible that you could have multiple answers.